Hello everyone, I am Karan Mashru. Welcome to this video. In this video, we are going to look at the solution of the problem, that is circle of strings. First of all, let us start by understanding the question. What does question say? Question says that given an array of lowercase strings a of size n, determine if the strings can be chained together to form a circle. So basically we are given an array of strings, and the strings in this are lowercase letters, and there are n strings in the array, and we need to tell whether these strings can be chained together to form a circle. Now how can we chain strings? It is given further. A string x can be chained together with another string y if the last character of x is the same as the first character of y. So if the last character of one string is same as first character of another string, then they can be chained together. For example, one string is a b c d and another is d e f. So you can make a link between them and chain these two strings. Okay. If every string of the array can be chained with exactly two strings of the array, one with the first character and second with the last character of the string, it will form a circle. So at a given time we can combine all the strings, we can chain all the strings in such a way that every string is chained with two other strings, one with the help of the last character and one with the help of the first character, then they will form a complete circle. And we need to tell whether we can combine, whether we can chain all the n strings at one time and form a circle. Okay, so we need to tell that. For example, for the array 4 geek, rig and kaf, the answer will be yes, as the given strings can be chained as for rig, geek and kaf. Okay, we will look at the example so you will have a better clarity. Okay, for example, here abc, bcd and cdf, here you can combine this string abc with cdf, but cdf because here c is the last character and c is the first character, but this cannot be combined anywhere further, right? This string cannot be combined on the right hand side because the last character is f and here there is no first character f. So we will not get a complete circle and the output is 0. Here it is a b, b c, c d and d f. These can be combined. We will also look at an example so you will have better understanding, but let us look here. AB can be chained with BC, BC can be chained with CD, CD can be chained with DA and DA can be chained with AB. So AB is chained with this and this, BC is chained with this and this, CD is chained with this and this, and DA is chained with this and this. So we will get a complete circle. So the output is 1. You don't need to read input or print output. Your task is to complete the function isCircle, which takes the length of the array n and the array a as input parameters and returns 1 if we can form a circle or 0 if we cannot. The expected time complexity is big O of n and expected auxiliary space is also big O of n, and the constraints are given here. So now if we think about solving this problem, then first of all let us understand this problem in a better way. So basically what they have said is we can chain one string with another string if the if the ending character of one string is the same as starting character of another string, and we need to tell whether we can form a complete circle by chaining these strings. Okay, so let us look at this example. So this is a x y b and this is b p q r c. So your last character is b and your first character is b, so this string can be chained with this string. Let me name this string s1 and this as s2. So I chained s1 with s2. Okay, now here the last character is c and the first character here is c. Let me name it s3 and let me name it s4. So s2 and s3 can be chained together, so s2 and s3 I have chained together. Here the last character is d and here the first character is d, so I can chain s3 and s4, so I will chain s3 and s4. Here the last character is a, here the first character is a, so I can chain s1 and s4, so I will chain them together, so I will form a complete circle. So this is for this the answer would be yes or 1 or true because they can be chained together. Now one thing to note here is that we saw that B and B are matching, we saw that C and C are matching, we saw that D and D are matching, we saw that A and A are matching. Did we look at the characters in between? No. Here I don't care what are the characters is, even if it was xy or yz, or if it was nothing, or if it was only x or only y, it had no use. Here also I had no use of this character, here also I had no use of this characters, and here also I had no use of this characters. So the only important characters for every string is first and last character. First thing. Second thing, see what we can do is we can say can we write the string as like this. So I denoted this string like this. Okay, so I said this string a to b. Okay, because A is the first character and B is the ending character. Okay, I will represent this string as B to C. Okay, I will represent this string as C to D, and I will represent this string as D to A. Okay, now if the first character of a particular string is the same as last character of another string, then they can be chained together. So here this B, this is the outgoing arrow from B. So this is the first character of a string, and here it is incoming edge towards B. So this is the ending character of a string. See, what I am saying is, this is incoming edge, okay, and it is incoming towards B. It means B is the ending character of a string. Here B, this edge is outgoing. It means this is the starting character of a particular string, right? So I can chain this together. So I can write A to B and B to C. I have chained this B together. Okay. Now this C is has an incoming edge. It means this is an ending character of a particular string. This C has an outgoing edge. So this is the starting character. So I can combine this C and this C. So I will say from C to D. Now this D is incoming edge. So this is the ending point of a particular string, and this D has the outgoing edge. So this is the starting point of a particular string. So I can combine this D and this D. So from here D, the string is towards A. Similarly, I can combine this A and this A. So I can write like this. So here this is the this is what we got. And here it is forming a complete circle. So we can say that yes, it is forming a complete circle. So basically what we will do is, we will make a directed edges from first character of a string to the last character of the string. Okay, we will make directed edges from first character of ith string to last character of ith string. In this way I will form a graph. Okay, then after forming this graph, what I will see is, I will check for I need to check whether I need to check for two things. First is, for every node the number of incoming edges should be equal to number of outgoing edges, and the second is, the whole complete graph should be singly connected component. Okay, now why I need to do that, let's have a look at 2-3 examples and you will have a clear idea. Okay, so what I said that first of all we will form directed edges from starting point of the string to the ending point of the strings, right? And we will check whether incoming edge is equal to the number of outgoing edges for every node. That should satisfy, and the graph should be singly connected components. Then we can form a circle. Now why am I saying that? So have a look at here. Okay, so let's say after forming the graph and after chaining the strings, I got these graphs. Okay, here the incoming incoming edges is equal to outgoing edges for each and every node. Here the incoming edge is 1, outgoing edge is 1. Here the incoming edge is 1, outgoing edge is 1. Here the incoming edge is 1, outgoing edge is 1. Similarly here for all these 3 nodes. But this is not a singly connected component. What do we mean by singly connected component in a directed graph? It means that there is a directed path between each and every pair of vertices. Here we are not getting that. This is different component and this is different component. Now if we think about what would be the strings that would result in this graph. So there would be one string which would start from A and end from N to B. That will give me this edge. There will be one string which will start at B and end with C. That will give me this edge. There will be one string which will start with C and end with A. This will give me this edge. Now there will be one string which will start with D, end with A, one string starting with E, ending with F, and one string starting with F and ending with D. So this set of strings will give me this graph. Okay. Now as you can see here, this will not form a complete circle. So out of the two conditions, which condition is here not satisfied? Singly connected component. The graph should form a singly connected component. This condition is not satisfied here. Here the in degree of each node is equals to out degree. What is in degree? Number of edges coming towards the node. What is out degree? Number of edges going outside the node. That is satisfied, but this is not satisfied, so we cannot form a circle. Let us have a look at this example. Is this a singly connected component? Yes. Why it is singly connected component? Because here there is a directed path between each and every node of vertices, each and every pair of vertices. So how? See, from A I can go to B, I can go to C, from C I can go to D, from D I can go to E, from E I can go to F, and from F I can go to back to C. So basically starting with A, I am able to visit all the nodes, right? For starting with A, I can visit all the nodes. So if from any other node, if I can reach A, then I will be able to reach everywhere else also. See, what I am saying is from A you can visit all the nodes. Now let's say if I am able to visit from D, if I can come to A, then from A I can go to all the other nodes. So from D also I will be able to go to all the other nodes. So look here, from B I can go to C, then D, then E, then F, and then A. So there is a path from B to A. If there is a path from B to A, and from A if I am able to visit all the other nodes, I will be able to visit all the nodes from B also. Now from C to D, D to E, E to F, and F to A. So from C to A there is a path, and from A there is a path to all the other vertices. So from C also there will be a path to all the other vertices. Similarly from D I can come to A, so from D also there will be a path to all the other vertices. Similarly from E to A I can come, so there will be a path from E to all the other vertices, and similarly from F I can come to A, so there will be a path from F to all the other vertices. So basically there is a directed path between each and every pair of vertices in the directed graph. So this is a singly connected component. But here the in degree is not equal to out degree for every vertex. Remember, it should be true for every vertex. Now see here what was happening. It was resulting in two different connected components because of these strings. So when in degree is not equal to out degree, what is the problem that we will get? Let's have a look at it. So here this is a singly connected component which we saw, because from every node we are able to reach to every other node, but the in degree and out degree are not same for every node. For example, here for A, in degree is 1 and out degree is 1, so it is same. But for F, the out degree is 2 and in degree is 1. So this node does not satisfy the property of in degree and out degree. So even if one vertex does not satisfy this property, we will not be able to form a circle. Now, so this is basically the two conditions which we need to check, and you can solve it with the help of this. But now I am trying to give you the intuition behind why this will not work. Okay, so we understood here what was happening. If it is not a singly connected component, we cannot form one circle. Okay, let's see what will happen here. So basically, see, because of this edge, there will be a string starting with A and ending with B. Because of this edge, there will be a string starting with B and ending with C. Because of this edge, there will be a string starting with C, ending with D. Because of this, we will have a string starting with D and ending with E. Because of this, we will have a string starting with E and ending with F. Because of this, we will have a string starting with F and ending with C. And because of this edge, we will have a string starting with F and ending with A. Now let me name it S1, S2, S3, S4, S5, S6, S7. Okay. Now understand one thing. If I want to form a complete circle, each string can be attached to two other strings. One with the help of the starting character and one with the help of the ending character. So if one string has character C, let's say at the end, it can be used by only one other string which has C in the starting character and combine them. Multiple strings with C as the starting character cannot be chained, otherwise it will not form a complete circle. So look here, what is happening is, so let's say S1, okay. So S1 can be combined with S2, S2 can be combined with S3, S3 can be combined with S4, S4 can be combined with S5, S5 can be combined with S6, okay. Now look here. S6 cannot be combined with S7. S6 has ending character C, S3 has starting character C. So there is only one connection for S6, that is connect S6 with S3. Now see what I said, this starting character was used to connect or chain with S2, because here also the ending character is C, here also the starting character is C. So it was used for that. So the starting character of S3 was used to chain with the ending character of S2. So we have used that character here. Now there is no other string which starts with C. So if I connect S6 with S3, I will not get a complete circle. Why? Because what does C, if I look at C, there is 2 incoming edges and 1 outgoing edge. It means, what does outgoing edge denote? Outgoing edge from C denotes that there exists a string with starting character C, that is this. And incoming edge C denotes what? Incoming edge C denotes that there are strings which are ending with C, right? So there are 2 incoming edges and 1 outgoing edge. So we are not able to connect this in a complete circle, right? If there was one more string with ending character C, then C would have if there was one more string with starting character C, then C would have one more outgoing edge. So its incoming edge are 2 and outgoing edge are 2. So I would be able to connect S6 with that another string. Now you get the point why the incoming edge should be equal to the outgoing edge, because every string can be connected to exactly 2 strings, right? If we repeat the S3 to connect with S6, we will not form a complete circle. So if the number of incoming edges is equal to the number of outgoing edges for every character, then we will form a complete circle. Okay, so here incoming edges is not equal to outgoing edges. That is the that's why it will fail. Now let's look at the last example. Here both the conditions are matching. See, here the number of incoming edges 1, outgoing edge is 1. Here the incoming edge is 1, outgoing is 1. Here the incoming is 1, outgoing is 1. Here incoming is 1, outgoing is 1. Here incoming edges are 2 from D and from A, and outgoing is also 2. Also, this is a singly connected component because there is a path from each and every node between each and every pair of nodes. You can check it by yourself. So what would be the condition here? There would be a string from A to B because of this edge. There would be a string from B to C starting with B and ending with C because of this edge. There will be a string starting with C and ending with D. There will be a edge starting with D and ending with B. There will be a edge starting with B and ending with E. There will be a edge starting with E and ending with A. So this is S1, this is S2, this is S3, this is S4, this is S5, and this is S6. Now S1 can be connected with S2, S2 can be connected with S3, S3 can be connected with S4, S4 can be connected with S5, S5 can be connected with S6, and S6 can be connected with S1. So this will form a complete circle. Please look here. Here the ending character was in S4, the ending character was B. So I needed to connect it with a string which has a starting character B. So S2 has a starting character B and S5 has starting character B. But S2 was already connected to 2 nodes. So S2's starting character was used to chain with S1's ending character, that is B. So that's why I cannot chain S4 with S2. That is the problem which we were facing here. But here, since the number of incoming edge is equal to number of outgoing edges, so the number of strings ending with B and starting with B have become equal, and we were able to form a complete cycle. Okay, and so it will work. So basically, first of all, we will check whether the number of incoming edges is equal to number of outgoing edges for each and every node. Second, we want it to be a singly connected component. Now, in order to check if it is a singly connected component, that is, there exists a path between each and every pair of vertices, you might need to use Kosa-Raj's algorithm, but that is a tough one. What we can simply do here is, since number of incoming edges equal to number of outgoing edges, we can simply randomly run a DFS from a node and see what are the number of nodes visited. If starting from a random node we were able to visit all the other nodes, then it is a singly connected component. How? Because see, number of incoming edges is equal to number of outgoing edges. So if I visit a node using an incoming edge, there will be a respective outgoing edge which I can use and go to another node, and in this way I will able to visit all the connected components, all the nodes. So basically we will simply run a DFS from a particular node, and if we were able to visit all the nodes, and if the number of incoming edges is equal to number of outgoing edges for all the nodes, we will return yes, otherwise we will return no. Now let's look at its actual implementation. So if we look at the actual implementation, so this is the string vector which is given in the input, and n is the number of strings. I have taken one adjacency list of size 26 because we will be forming a graph from the start. We will be forming an edges from starting character of one string to ending character of that string. Okay, so those characters will be used. So that size I have taken as 26. I have taken some few variables which we will see where we will be using. I have taken one count variable of one C variable of size 26. Why? Because I also need to check whether a particular character exists as a starting character or an ending character. If that does not exist, then there is no use of considering it, right? This is used for incoming edges, this is used for outgoing edges, and this is visited array which will be used while applying DFS. First of all, I have marked all of them as 0 and visited of I as false. Then for I equals to 0 to n, that is for all the strings, m is the size of the string, I'll make a directed edge from starting character to ending character. So a of I 0, that is first character, minus 97, I'll remove the ASCII value and I will do a directed edge to the last character, that is ith string and character m minus 1. Okay, and I will say counting of a of I 0 minus 97 plus plus, that is this character exists as a starting or ending character in the string. Okay, so I have incremented its counter, and outgoing edge from the 0th character is plus plus and incoming edge to the last character plus plus, and also counting of the last character plus plus. Okay, then with the help of this C array, I have count the total number of characters, because at the end I will apply a DFS and I will check what are the total number of visited in one DFS. So I will match it with the total number of characters, okay, in the graph. So if C of I is greater than 0, total plus plus, so this will give me the total count of characters which I need to check. Now for all the characters, if the incoming edge is not equal to outgoing edge, I will mark the flag variable plus plus and immediately break. Flag variable was initially marked as 0. Whenever we find a condition which is not allowed, we will mark the flag variable as 1. So I mark the flag variable as 1 and immediately break it. And if flag variable is greater than 0, so it means this condition was true for some index, I'll directly return 0. If not, then I will call DFS from a random character. Now random character should be at least present in the graph. So I will run a for loop from 0 to 26, and if counting of I is greater than 0, only in that case I will call a DFS from ith character, because if counting of I is 0, that character is not present in the graph, so there is no point making a DFS from that. So I'll call a DFS from ith character, I'll pass the adjacency list, visited array and count array, and I will break, because I want only one DFS and I want to see whether I am able to visit all the nodes. If count is equals to total, so I will pass this count array which will initially be equal to 0, and whenever I visit a new node in the DFS, I will increment its count. So finally, if count is equals to total, that is in degree is equal to out degree for all the nodes, and the total number of nodes visited in a DFS equal to total number of nodes present in the graph, I will return 1, otherwise I will return 0. Now let's have a look at this DFS function. So in DFS function, first of all, I'll mark the ith node as visited as true. I'll increment the count of number of nodes visited. Then for all the elements which are in the adjacency list of I, if they are not visited before, I'll simply call a DFS. So in this way, I'll know what are the number of nodes that are visited in the count variable. Okay, remember count is passed with the help of the reference, because that was declared in the isCircle function. Okay, so what will be the time complexity? The time complexity will be, see, we are using some for loops of size 26, and another than that we are basically using a DFS. Now DFS will also contain how much? It will DFS takes number of edges plus number of vertices time, right? And we are also using a for loop of size n to mark the edges, right? Because there is a edge between starting character and ending character of each string. Now big O of 26 is constant, n is the number of strings. What are the number of edges? Edges is nothing but the number of strings, because we are adding an edge from starting character to the ending character of one string. Okay, so what are the number of vertices? Vertices can be at max 26. So this will nothing but big O of n. And what will be the auxiliary space? The auxiliary space, we have used some vectors or arrays of size 26 plus we have used the adjacency list which contains the number of edges. Number of edges are equal to n, so this is equal to n. So this will be equal to big O of 26 plus n, and this will give me big O of n only. So this is the time complexity and this is the auxiliary space. Now let's submit this code. So let's submit it. So we have solved this question successfully. I hope you have understood this solution completely. Thank you.